Hello and welcome back to my organic chemistry video. So today we're just going to be going over some intro to synthesis. So what I mean by that is I'm going to give you a regular benzene ring and you're just going to follow the reactions, see what adds on, what doesn't add on by utilizing your chart. So moving forward, let's say we start with a regular benzene ring and we add Br2. Actually, before we start, I would like you to pause the video and try and figure this out yourself and then come back and see if you did it correctly. So I hope you paused the video, and now I'm going to show you what actually happens with this. So with Br2 and FeBr3, you add on a Br. After that, you're then going to do an acylation, and since we have a Br on here now, that means it prefers to either add on ortho or para, but due to sterics, it's going to add on at the para position. Okay, now we're doing MgH2O. So MgH2O just removes the halogen. It can remove chlorine, bromine, iodine, OTF, any halogen except for fluorine. So remember that. So now then when we just get this, now we're going to react this with HNO3 and H2SO4. Now all that does is add a nitro group. However, we now have an electron withdrawing group on here, which I will highlight in red. And electron withdrawing groups prefer to add on at the meta position. So we'll add this NO2 or nitro group on at the meta position. Now we're going to do Zn/HCl. Now that just reduces the NO2 into an NH2 group. So you would get something that looks like that. Now if you do HONO, that now turns the NH2 into N, triple bonded to N, positive charge on this N, and this remains constant over here. Now if you do H3PO2, that just takes the N triple bonded N, if you go to your chart, and turns it into an H, or a hydrogen. So it would look like this. However, since we don't really want to draw out hydrogens, we'll just ignore that. And this would be your final product. Look like that. And this is your complete synthesis of this problem. So next problem. So we're starting with just a regular benzene ring. Once again, it's electronically equivalent at all 6 points. And we want to react that with HNO3. Like last reaction, HNO3 just adds an NO2. So we'll put an NO2 on here. Now then again, with a zinc HCl, that reduces the NO2 into NH2. HONO, once again, turns that into N, triple bonded to N, with a positive charge. Now then with HF, that would then replace this, N triple bonded to N, with a fluorine. And then once you react that with HNO3, that would add an NO2 group on. However, since we have a fluorine on here, which is a halogen, halogens prefer ortho or para. Para usually preferred unless sterically encumbered at that position. It would add it on at the para position. Now, what's unique about this is we can now undergo what's called a SNAR reaction. If you watched my previous video, you would know what this is. And that means that this leaves, and the negative OH would come in and attack here. And you would get something that looks like this. And now that if we want to do Me with iodine and NaH, that would then take away this hydrogen and it would replace it with a methyl on the oxygen. And on your chart, that would be right around the Sandmeyer reactions. And it would leave the NO2 on here. And this would be your complete molecule for this. So moving on to the next example. This one's pretty fun actually. So we're going to start with just regular benzene. Once again, it's electronically equivalent at all points. So we'll add the NO2 on wherever we want. I like to add it on at the top because it gives me more room to work with the molecule. NO2. Zinc HCl turns this into, once again, NH2. Now here's where it's cool. Now when we react with HNO3, guess what happens? Well, my friend, you get what's called an explosion. Boom goes the dynamite. So that's a pretty unique reaction that can occur using your chart. And let's move on to the next example. So we're going to start with Br2 and FeBr3. Once again, it adds Br on, and then when you react that with magnesium, it does this. And then let's do this with CO2, then H+. When you react this with CO2 and then H+, it replaces this group right here with a carboxylic acid. Once again, we now have an electron withdrawing group on here, so now we actually have to start looking at the electronics. Since it is an electron withdrawing group, it's going to prefer to add on at the meta position. And this is going to be an acylation. And when we do this, all that happens is we don't have to worry about a rearrangement because it's already going to be a secondary carbocation once this iodine leaves. So this is what would actually be attacking at this meta position, and it would attach here, or it could attach here. Since both places are electronically equivalent, you get to choose where you want to attach on at. I'm going to prefer to attach it on here just for convenience reasons. Now then, what happens now? Well now, oh, and I forgot to add this on. This still remains constant. Now when you react this with KMNO4 and NaOH, all that does is turn the carbon chain into another carboxylic acid. So now this would be your final product. And from there, we're going to say this reaction is complete. So, another example. Pause the video and try and figure this one out now. Okay, hope you pause the video. So, Cl2 with AlCl3 is going to add a chlorine on wherever we want, since it's once again electronically equivalent, since it's just regular benzene at this point. Then when we react this with magnesium, it's going to do the same thing it did in that last example. However, instead of having chlorine on, instead of having bromine on there, we're going to have chlorine on here now, since that's the halogen that was present up here. Now then, once we react it with this molecule right here, all that happens is whatever halogen is present here replaces the halogen that is present on that Mg. So we're going to replace this Cl with a fluorine and get rid of that magnesium, and this would be your final product right here. And that's all I have for today, guys. It's a pretty short video. I hope you paused the video and tried each of these on your own before getting the answers. And I'm just going to try and ease you into the synthesis stuff. I think this is the best way to do it, is just kind of mess around with your chart and figuring out reactions. And within the next couple of videos, we're actually going to start doing problems in which I give you a molecule and I want you to design it yourself by utilizing electronics and utilizing different reactions. So I hope you guys have a wonderful day and stay frosty.